welcome to my first machine learning video where we'll be covering machine learning, where machine learning is used for multiple applications nowadays, like AI, chatbots, and other things. So we'll basically be using Python as a programming language for machine learning throughout this course. So hopefully you already know Python, or you'll be watching my Python videos that will be coming on some certain days. So we'll go through a brief overview on machine learning. It's a way of taking data and turning it into what we call insights. We use the computer's power to analyze examples from the past and build a model that can predict the result for new examples. We encounter machine learning models every day. Like, you may not know it, but it's there. Like Netflix, YouTube, Amazon, any online shopping or streaming service, they usually have machine learning that's being used there. So whenever you see something on your recommended, or let's say if you're a person who watches a lot of cartoons and you find anytime there's a new cartoon, is right there, just waiting for you. That's basically Netflix taking your information and then learning what you like or what you might like, and then giving the output to it. Now here in this course we will learn several techniques for solving machine learning problems, and like I said, it can be used to make a chatbot. Also, in some cases it's used for image recognition or even to detect spam. So since we're using Python, there are various packages in Python that are helpful in machine learning. Like, we'll be using pandas, numpy, matplotlib, and scikit-learn. Pandas is used for reading data and data manipulation. Numpy is used for computations and numerical data. Matplotlib is used for graphing data, and scikit-learn is used for machine learning models. Each of these packages are quite extensive, but we'll just review the functions that we will be using, and also I will be showing you some basic statistics because it's the foundation of machine learning. So I'll review them in this video before moving on to anything else in the next video. So I hope you'll be practicing on your side, because I'm giving theories and I'll also be giving examples here on my side. So in machine learning, we usually talk about supervised and unsupervised learning. Supervised learning is when we have a known target based on past data, like predicting what price a house would sell for. And unsupervised learning is when there isn't a known past answer, like, for example, determining the topics discussed in, like, let's say a restaurant or a movie review. In this course we'll be focusing on supervised learning because it's more easier. And within supervised learning there are classification and regression problems. Regression is like predicting a numerical value, for example, predicting what price a house would sell for, and classification is predicting what class something belongs to, like, for example, predicting if a borrower will default on their loan. We'll be focusing on classification problems, and these are problems where we're predicting which class something belongs to. So at the end of this course you'll have probably enough knowledge to take a classification dataset and use Python to build several different models and determine the best model to solve a given problem. Okay, so that's basically a rough overview on machine learning. So now we'll move to the coding part. So machine learning relies heavily on maths. So maths has to be a strong point, especially statistics, I guess. So we'll move on to the first topic, which I'm going to be teaching today. That is averages, percentiles, standard deviation, and variance, and implementing them in statistics with Python. So first we start with averages. So when dealing with data, we often need to calculate some simple statistics. Like for example, let's say we have ages of people within a class, like 15, 16, 18, 19, 22, 24, 29, 30. These are 8 numbers. I want 9 so that we can get medians and means easy. And 34. Okay, let's save that. So the mean is most commonly known as average. Like we just add up all the values and divide by the number of values. So here it would come to 207 if you add all these numbers here, and if you divide it by 9 it should come to 23. Now the median is the value in the middle, and in this case, since there are 9 values, the middle value is the fifth, which is 22. Now in statistics, both the mean and median are called averages, but in layman's, average is just the mean. Okay, so here we mostly consider mean and median as averages, not just mean itself. Now percentiles, the median can also be thought of as the 50th percentile. This means that 50% of the data is less than the median and 50% of the data is greater than the median. This tells us where the middle of the data is, but we often want more of an understanding of the distribution of data, like whether it's like how it's distributed, whether it's evenly, unevenly. We're just interested in that. We'll look mostly on the 25th percentile and 75th percentile. So the 25th percentile is the value that's 1/4 of the way through the data, and the 75th percentile is the one that's 3/4 of the way in the data. So that should be somewhere here as the 25th percentile. So since 18 is greater than 16, that will be what we're working with as the 25th percentile. And when we go here, it will take the similar way, and our 75th will be 29. So this therefore means the full range of our data is between 15 and 34, and the 25th and 75th percentiles tell us that half of our data is between 18 and 29. So this helps us to gain an understanding of how the data is distributed. Okay, so like I said, if you find somebody just saying 50th percentile and you're looking for the median, it's just the same thing. Okay, it's 50%. Now if there is an even number of data points, to find the median or 50th percentile, you take the mean of the two values in the middle. Okay, just take the mean of the two values in the middle. Now standard deviation and variance. We can get a deeper understanding of the distribution of our data with the standard deviation and variance. The standard deviation and variance are measures of how dispersed or spread out the data is. We measure how far each data point is from the mean. So we have our ages here again. So if you remember, the mean is 23. Let me just type that down. The mean is 23. So if we calculate how far each value is from the mean, like for example 15 is 8 away from the mean, because it's 23 minus 15, that comes to 18. So if we do that, here is the list of all the distances. So I came prepared with this for 1, 1, 6, 7, 11. Yeah, that should be the distance between all the numbers. So when we square all these values and add them together, like 8 squared plus 7 squared plus 5 squared, etc., etc., it should come to 362. So when we divide this value by the total number of values, that gives us the variance. So if we divide it by 9, that will come to 40.22, and that is basically what we know as variance. Okay, that's our variance. Now if we get the square root of this number, which is 6.34, that is our standard deviation. So that's how you get both of them. So this also helps to know how our data is distributed, especially when we are plotting graphs. It helps show us how it's distributed. So even though data is never a perfect normal distribution, we can still use the standard deviation to gain insight about how the data is distributed. So now that we have gotten all that, we'll move on to the most important factor before I end this video: statistics with Python. Now we can calculate all these operations without a calculator. We can just use Python to calculate the mean, the median, the variance, the standard deviation, and even the percentile, by the use of the Python package that I had said earlier, NumPy. So we will use NumPy for manipulating these arrays, but for now we'll just be using it for these statistical calculations. So if you want NumPy, then you'll have to import it, and before importing it, you'll have to do a pip install on your command prompt, or if you're using Linux like me, or Mac OS, you'll have to, I think so, you'll have to do the same thing, pip install with your terminal. So after you've done that and you've downloaded NumPy, you'll need to import it. So we'll first start the code: import NumPy as np. So np just helps us to, it's like a nickname, sort of. So it's basically just to shorten our code and not just continuously write numpy dot this, numpy dot that. So now let's say the data that we had earlier on, which was these numbers. You can rewind the video to get to see if the mean and everything is correct. 19, 22, 24, so that's basically 1 2 3 4 5 6 7 8 9. Yeah, I believe that those are the correct numbers. So now that we have our data, we can use the NumPy functions in order to get the mean, median, standard deviation, and variance functions that we just passed in this data list. So we can also get the percentile and everything. Yeah, so in order to get the mean, we'll start by invoking the print function so that we know it's the mean. Put double quotations, np dot mean data, and save. So now if we run that, yeah, that should give us the correct mean. Okay, now if we want to get the median, that is also the same way. Print so that we know it's the median, comma, np median data, and then we save. If we run it, it should give us the correct median, which is 22. Okay, hold on, let me close the shell. So now we move on to the percentiles. So if we want percentile data, like for the 25th and 75th percentile, all we have to do is just do print, and then to indicate that it's 25th percentile, comma, np dot percentile. Now this is the important part. To indicate that it's the 25th percentile, we will put 25 there to indicate it, and once we do that, it should give us 18, if I'm not wrong. Yeah, so 25th percentile, 18. Now if we want the 75th, we do the same thing. 75th percentile, np dot percentile data 75. So that I believe should give us 29. So let's just make sure. Yes, we got the correct answer. And finally, for the standard deviation and variance, print. I'll also put a print here. So for the standard deviation, we just so that we can know it is standard deviation. So here it's np.std, so that's short for standard deviation. Then we put data. I will run the code as well with variance. So variance, comma, np dot var data. Yeah, so now it should give us the standard deviation and variance, which I believe was somewhere of 6.3 and 4.22, something like that. Yeah, 6.34 and 4.22. But you know, Python, it does it more accurately of displaying floats, so that's what you get. So NumPy is not only a package but also a Python library that allows fast and easy mathematical operations to be performed on arrays. Okay, So when we have multiple numbers like this, NumPy is just good for doing the work quickly and fast. So that's it for today's video. I'll be posting the second one maybe a few days later from now. I don't know, but just stay tuned. Put the bell icon in order to know when I'll be bringing them. So that's it for today. See ya.